mai haere mai, and welcome to this webinar. I am Dwayne Wilkins. I'm a geospatial advisor here at Land Information New Zealand, the capability building team. And I'm here with my colleague Karl Baker, who is Master Cartographer from the Topographic team here at Land Information New Zealand. So thanks for joining us. So we're talking about finding and using New Zealand's popular GIS data layers, and today we're focusing on topographic data. Now, if you would like to access the document that you'll see us referring to today, and I'll just very quickly share my screen, and then Karl's going to snatch it back. I'm going to put this link on the chat so that you can access this as well. Haere/topo, so hae.re/topo. Awesome.
You got that?
Yep, good to go.
Cool. So you don't need to know about my MasterCard receipt. So today we're going to go over in three main parts. So we'll talk about topo maps and what they are, and I've got this good story here that uses our topo maps quite well, or very well, and we're going to go into the topo data dictionary so you can sort of understand what the data is and find out more information about it, and then we're going to get into the LDS and where to get data from. And I've got a new headset, so I'm just trying to work out where the less breath is, sorry.
Okay.
So when we create our topo maps, we have our sort of perceived main uses of them, and that's people going out tramping, needing a paper map. If they have planned their walk, they do their best not to get lost. When they do get lost, then land search and rescue come and find them, okay? But when we look around the web and see our Topo50 maps, everybody uses them for everything because it's this sort of one national coverage of mapping that we have for New Zealand. And we've been doing it for a very, very long time. So this story talks about Glacier Mounts, and it comes down to this map here. And it's a 1979 topographic map of the Tasman Glacier. And what it actually is, it's a NZMS1 series, so our first series of topographical maps that we made. And this is when Lands and Survey sort of made the maps, and we did everything from the surveyors going out and putting in ground control. We had our own planes. We had loads of photogrammetrists. We had loads of surveyors. When we finished the work, we had field checks going out into these really remote places. And there's a video on YouTube called An Inch to the Mile, and it's from 1971, and it explains how topo maps were made back in the day. It's an interesting watch if you like watching 1970 movies. Lots of brilliant old cars, but it really shows the way that the map was put together and just how manual a process it was. It took, to make the first topo NZS1 map, it took about 5 years, and that was one map. And so this map series took us through from the late 1930s to the late 1970s. And I'll just highlight some things. Can you see my mouse sort of moving around?
Yes.
Yep. So on the right-hand side here, we have our vegetation with sort of trees, symbols with green in them, our relief shading through the hills here, our relief shading up through the riverbeds. Very, very time-consuming, beautiful looking maps showing our river channels and that type of thing as well, and lots of text. There's a part of it here, hut and plane table site. So very detailed, took a really, really long time to make, all manual. Another point I'd like to make is that when we're using these maps as evidence, you really need to know where the data has come from and when it was made. So this map states it's 1979. I believe this is actually the last edition of this map, but the actual aerial imagery that it was taken from is actually 1964 and 65, and you can see that on the published map, which you can actually get digital copies of as well. So we then move into the pièce de résistance, the NZMS 260 maps. These used NZMG, which apparently is one of the greatest projections ever for New Zealand. We changed to NZTM to bring us in line with the rest of the world. But from a cartographic sort of point of view, these were seen as the best maps we ever made, and they were really they were going from late 1970s. We finished off the last one in 1997, I believe, when I joined Photogram in Wellington. So once again, it's taken over 20 years to map the whole country. Additions were done, but we start to see on the right-hand side here that we have a sheet join. And so one of the problems is when we create data over many years and using different operators, our Murchison River has two very different representations either side of that line, and that's something sort of to be aware of in the data. So I'm going to give a lot of things that are really good about our data, and I'm going to give a lot of things that aren't so good about our data because we need to know where sort of we fall down. So the part of the story is explaining that there was no Tasman Lake in the 70s, and then by the 90s there's been this massive mount and its retreat, and we can see it in those other areas. So this is where Topo50 data really sort of shines, because you can see our 1K grid squares on the map. You can get a representation of scale, and it's telling that really big picture story. This is not property information sort of level. And again, our relief shading is absolutely brilliant through here and through the rivers. And so then we move into the Topo50 data, which is our current map series. And when this series was released in 2009, it was stated around the world that we switched overnight from one map series to another. And so all it was we sent it out in a different projection. It's exactly the same database, all the same data in a different projection and a different sheet layout, and we'll talk about that as well. So one of the problems was because we didn't remap everything, you again get these sort of sheet line images and holes in the data and mismatches on the edges because we weren't updating that. And again, this final map is from 2019. So I believe this data is taken from the Maps Past, which is a brilliant website that shows all our maps, and you can flick through 10-year cycles, but it kind of misses intermediate releases of the data and that type of thing. And also this, if you want a story about Glacier Retreat, there was actually a 2020 release of this image, which takes this Tasman Lake has grown another 1.5 kilometres. So, that's the story. And there's lots of things that you notice when you flick between these images. So a big thing would be around our names, right? So we get all these names that then appear dual names. So the Geographic Board's been around since 1946, I believe. And then, there was a treaty claim just before the 2000, and that really changed the focus, or it gave momentum to our dual naming of all our features on our map. So as a cartographer at Land Information New Zealand, we don't decide what is put on the map, mainly. We're driven by people supplying us information and putting it on. And so the Geographic Board names are a really good example, because these are the official names and that's what we're putting on the map. Then there are holes in the country where we don't have official names, but we do want information on the map. So we kind of had to add those as well. But any name that you see on the map should reflect what's in the GeoBoard, and they have a good way of checking all our maps when they come out. And so, talking about those names, when we changed that map series, you can see Liebig Range here has got 2 lots of labels either side of the sheet line. In the new release, there's only one that's been consolidated, but that's another that's a sort of artifact of the way that we do Topo50 maps, is that Tokoroa appears as a name, as a point on 3 different sheets, because that's the way it is.
Just on those names, Karl, just if folks are interested, on our list of future webinars, I did actually have one sort of tentatively scheduled in as place names for geospatial practitioners. So if you would be interested in a separate webinar just on how to get the most out of all the different place name sources, then let us know and we can schedule one in for that in the future.
Yeah, and it's a really important thing from sort of mapping point of view, because we know our snow and ice is retreating, but we can't do much with the topo maps, because once the glacier is gone, we actually have to rename the features that we're going to be mapping on it. So it's something that's certainly on our radar and we're discussing. We know it's there, but it is actually a big thing to go through and change. So this is a great story because it just shows us map, it shows the differences in it, and it's something that I found by mistake, but it really it highlights a lot of things. If we're looking towards the future, you'll get my comment that our relief shading through here is absolutely brilliant, really highlights these areas. We do lose that in the current map. There's a AI machine learning process that's going on that Roger Smith from Geographics has been involved in, and it's Swiss Topo using machine learning to actually recreate relief shading using the methods that our cartographers did when they did it manually. And what that does is it highlights details in the shadow side of the hills, and actually shows the a better, just a, I don't know, that's better, clearer, just a more artistic, and you get more information from that sort of shading. Right, so that's our sort of introduction to it.
Cool. Hey, I've put a link to Maps Past and the geographic board on the chat for those interested, and also added them into our reference document there as well.
Oh, so if we go to our Topo data link, so sorry, this is a bit out of order. No, it'd be good if I could minimize that ever so slightly. Sorry, that dodgy toolbar that comes down when you go to look for things. Here we go. Right, so the New Zealand Topographic Data Dictionary. So this explains all the information that's actually on our maps. Not many people are aware of it, and we don't really maintain the site because we still say we deliver it in LIS, LIFF format. We've only just recently
LISF format, LIFF format.
had the ability to actually change the site. So that's one of the things that we're going to update. But most of the other stuff is up to date and good. So when we talk about our topographic database, we have this idea that we have objects and entities. And so we're on the object index here. So an object is an airport pointer, an airport polygon. And those are the two types of features that we show on our map. And then we have this entity class of airport. And so this helps because when you look for something like a coastline and go to C because you expect it under coastline, the entity, I believe, is shoreline. But under the object class, you can go to C for coastline and find a coastline. Right, so when this is really basic GIS stuff, we have points, lines, and polygons. All our features have relatively simple names, and they've got that end on it of a point, line, and polygon. So the thing in here that we also have, which is kind of cool, and I find a nice looking symbol, would be that you can click on a slip edge. You can see examples of what it looks like on the map, and then you can actually also see how we actually physically make that symbol. Okay, so one of the things that I really like to bring to LINZ is the fact that we are giving people data, but we're not really giving them the information how to use it properly and the understanding of how to use it. So having this stuff available to say, this is how we symbolize the map, this is a start for you. We find that, I believe that will be actually quite helpful in that sort of the cartographic view. We give examples of the features that we're actually showing. And then we give you the information about how these features have changed over time and what attributes you can see changing. So we change very little. We've dropped off a few features. I think there's 147 features in there now. And another point I'll just make really quickly here, and I always decide that I should be in entities, is an R, and we have this thing called a restricted area. So one of the few things that you don't see in the LDS is the Waiouru military training area. It's a big red line on all our maps, and I sort of point out that that's really the only line or boundary we actually show on the maps. The rest of it is topographic data. We're mapping what's on the ground. It's not boundaries, and the idea is that you have this topographic data that you can then put your boundaries over the top and explain those stories. So we see that a lot in mobile apps, putting hunting areas and that type of thing over the data, and that's we contribute that sort of base map to it, and then these applications bring all the other information from other sources. And that would be about enough, I believe, for the Topo Data Dictionary. So
it's interesting because it's, it's a different way of thinking about data than we might have thought.
Yeah, because like the water course, we want to know, and I'll relate this as well, that, I suppose that's in the LDS part of it, but remember when we made these maps, they were made up of plates of different colors. So we tend to group our features, green was vegetation, blue was water. So our water course features, these are all the features that appear as blue on the map. I think waterfall gets the winning for most object codes. So we have a centerline, an edge, a point, and polygon. And there are a couple of tricky things that we actually show. So I get this asked a little bit, maybe is a wrong place. People say to me, how do you do your rocks? And our rocks are polygons along the coastline. And there's the symbol that we use, but that doesn't actually tell you how we do it. And that's another webinar within itself. So that gives the rocks facing away. We cut off where the coastline is. You can still see the coast. That's a really complicated feature. And so I suppose in our Topo50 database, when we're maintaining, so for our labels, for instance, we have customized tools that were built in the mid 2000s, and we have something like 32 different text placement tools or options when we're placing our text, and it's similar to the capture and that sort of thing that we do as well. So it's certainly bespoke and made for LINZ and the work that we want to do. Right, so my little favorite thing here is Map Chooser. So Map Chooser is about...
can you zoom a bit on your screen?
Yeah, okay.
Yeah, thanks, man.
So Map Chooser is where you get your TIFFs and GeoTIFFs from, specifically for a sheet and not for going to the LDS. We do a crop, and then we get extra bits and that type of stuff. Here we can actually go and get sheets, and we can have the actual printable map, so that's got the legend and everything on it, or you can grab the map window. And if I do it properly, so we start off by going to the Topo50, the Topo250 map 7 freeze cape, and it has the maps for it. And you scroll down here and you get these image files. So you click on those, and those will grab the 250 map for that area. So a little bit not quite user-friendly. Download should be at the top and that type of stuff, but don't worry about that. And then we can click onto our Topo50 map. And again, you can grab the TIFF and the GeoTIFF. And so if we grab the GeoTIFF here, I believe we claim that we cover all of New Zealand. There's an island out here where we missed the rocks by 20
East
meters. Island. I think when we get onto the LDS, we'll show that when we're doing it in the NZMS 260s, we weren't that tight with the rules. We could extend sheets a little bit bigger than what they were. There's a little bit more overlap. We did all these things to fit everything in. When we went to Topo 50, it was very much these are the standards and specifications, and this is what we must follow. And we had to bend the rules a little bit there as well. Right, so now let's get into some LDS and grabbing some data. And what's the top of our list?
We're going to look at the coastline, doing a search for the coastline.
Cool. So we will, from the work that we've done on the LDS, we've got information about how do people actually get into the LDS and how do they use it. So 48% of our customers now come straight out of Google. They're not actually going to the LDS. And I've got some pages here next to me, and there's a difference between now and 5 years ago. And so 5 years ago we had, let me check, we had 80,000 page views per week. Okay, so that's 80,000 people a week going to the LDS and looking for data. Now we've got, and this is a good thing about statistics, we've got 165,000 a month. So that shows that less people are using the LDS. But what it doesn't show is that we've now got 15 million API calls a week. So the LDS is there because people can now directly connect to it in a machine to machine. They're using WFS services and that type of stuff. So sort of that's the evolution of what we have. So the LDS is, searching. A quote that I get often is that it's great if you know what you're looking for. Problem is you're looking for things that you don't know. So we would type into here, and I wish I hadn't had it up.
Topo50 Coastline.
So we do.
Oops, got a typo there, mate.
That should be right. And so when you type in Topo50 Coastline, you can actually get straight into the LDS. And then if I had a map window, I'd be even happier. Here we go. Cool. And so talking about coastline, because when we talk about a coastline, this is the line that's on the topo map. And of course, what it misses is Resolution Island, because it is just the coastline and not the islands. So now we're in here, we do a search of coastline. And what you can see here is that we have our new New Zealand mean high water, but we have this extra layer called New Zealand coastlines and island polygons. So this is where sort of LINZ changes, but where this is actually, so the coastline is a linear feature. The coastlines and islands polygons is, a polygon feature. So you can symbolize with a blue line around the edge and a land, and it has all the islands, and the islands actually extend out quite a way. And so we've sort of done that because this is one of the things, a lot of people wanting a coastline, they want islands as well. So what we've done with the New Zealand coastline mean high water, and if you read the metadata and the abouts, which a lot of people don't, but apparently a lot of people do as well, from the numbers I mean, we have this purpose. So the purpose of this layer, it's the mean high water data set, and it's a first step towards improving our national coastline data for New Zealand. So we're working on a long-term project around coastal mapping, and a big part of that is joining land and sea. So if you've been to LINZ's presentations recently, or last 4 or 5 years, you would have heard about this joining land and sea project. We're nearing sort of a first phase of releasing information. So we don't actually have very much information on our web about this. And so the idea about this layer is that once we have our joining land and sea, once all our tide gauges are in place and we can actually recreate these different coastlines, and so we're talking about highest astronomical tide and all that type of thing, we will actually be delivering those different coastlines in a single data set, so people don't have to go around and search for lots of different layers. So this was
Karl, is that one a coastline or a coast poly? It's a line, I think, isn't it?
It is a line, and the
reason
that it's a line is because when we go to the data table, it's actually broken up into sort of a source. Oh, sorry, we'll click on that one. It's broken up into its source, the published date of the information, the scale it was captured for, and the coast category. So this is where it's sort of been a merging of a few different data sets. And so we have this category of flat coast, mangroves, rocky, sandy, and that type of thing. So this is actually, you can see some of this information from our Topo50 map. But having it as information by itself, you can actually hopefully be more useful to some people.
What level of scale is that designed for use at, Karl, that coastline?
So because it's got a scale, because the scale is relating to the source. So at the moment, most of it is 50K. So the idea here is that we can actually put in better coastlines that have more accuracy. Right now, we don't actually have a way of showing that. So there is actually a source field in there, and the source field is relative to what it should be used at. When Topo50 data is actually captured, we captured it at 1 to 25,000 and put 4 sheets together. but then there's other things that sort of bring into that accuracy. So the idea is that we can actually now replace parts of a coastline and give it the attribute of it was updated from a different source at a different time with a better resolution. So hopefully people will find that more useful. So our next topic of data would be?
Next one, so we've done coast and islands polygon, mean high water coastline. We're still trying to find a link for the joining the NZ. I think building outlines is our next one.
Okay, so when I was out in the field doing our virtual field trip for the schools, we were talking to some Landsar volunteers, and they said to me, oh, the small structures database that you've released is amazing. And I went, cool, what is it? And so what it is, I've already got them on, so that's cool. And if I had had the link that's in the file, it would have been better because we could have had...
Oh, grab that link if you want there, Carl. Just, yeah.
Where are we?
Up a bit. One. There we are. Yep, that one there.
Cool, so this is taking us to our area of interest, and I'll just check what we have on. Topo maps, right. And here we go, a little bit slow on the LINZ network this morning. So this is our building outlines data set, and this is super cool. I love this data set. Although you can see we don't have all the buildings, that's all right, because with this data, we can actually click on a feature, get the information, or not. It's not working for us, right?
Yeah.
Here we go.
Oh, yeah.
Just a little bit slow. Cool. So our building outlines is about adding this extra information on it and being really strong around the metadata. So there's a Medium blogs, I think, around as well with this data when it's been released. It's taken a few years for us to go from that pilot to in full production, and I think our most recent release we've included supermarkets. And that's sort of some work that came directly from the COVID response. So we have our persistent IDs on these buildings, and we have a little bit of information. We have this capture method, which is feature extraction, and we have the source imagery. So you'll see the source imagery for this feature is 2012, 2013, and that quickly tells you why these buildings aren't in there, because this is the latest New Zealand imagery. This is a LINZ base map service, has a latest data on it, and it hasn't been updated yet. So if I go back to NZMS 260s, when we updated those sheets, we've got files just around the corner, and while we don't have metadata on all our features, there's actually a letter from somebody about a homestead saying where its name came from and why it's there. And we've got our field check plots that are there. And so if somebody asked us about a feature on a map, we could actually go and find it. It would take a very long time-ish, but we could actually get to the bottom of that information. And our move to our Topo database, we've really lost that connection to metadata. And that'll sort of put me onto this idea about metadata, about our layers. And so in the future, we really want to be able to say to people when they come in, here is a feature, here's where it came from. And this feature extraction, we can actually supply the imagery and the code that was used to do that feature extraction, and it gives the public the opportunity to sort of question us and say, why things are there. And we it's just more about the openness. It can be rerun. We can realize when we've done something wrong because we've got the code, and we can fix the code and then rerun, and then we can actually add the features and that type of stuff as well. So when we captured in the past for our 260s, we were very particular about what we added onto the map, and it's the same with the Topo50 productions, that we're adding it from an image. We're pretty confident we don't have to have very much QA. We can see these, when we're mapping Topo50, we are at this kind of scale. So if you can see a shout about there, we're going to be confident that an operator is going to put that on. What we found with the building outlines was because it's feature extraction, and certainly in our earlier project, we captured container trucks on a road. Yeah, and sort of thing came through it. So it really moved our focus from being data capture from a cartography point of view to be data processing, and that's where our data team comes in, and they do they spend lots and lots of time doing the QA and sort of changing the way that we do the work. So from a lazy cartographer point of view in the future, we just bring the map together and print it out like we used to, and that's for the buildings. Linz has taken, we're doing that work. For the likes of our railway lines and our transmission lines, we're getting that source information from Transpower and KiwiRail. We're getting it by services. All we're doing is when they share their public data, we work out what's different. We then bring that difference into our data, and it really focuses us on the work that we need to do. And I suppose there's a good point to make, that when we maintain our information from a Topo50 point of view, we still maintain by sheet extents. So when we get, there's no point in updating a sheet if you're using the same real image from 8 years ago. I would say, okay, from 4 years ago, when there's new imagery coming in a year's time. So these are sort of the intricacies that we have a map management tool. We work out when our printed stocks are running out, we work out when we're going to get new information, and that really plans our work across the entire topography team. So that's sort of a bit around. Oh, and then we chose this area, Dwayne, because there's another thing I'd like to point out.
It was
the trees.
Yes. Yep.
Okay. Oh, so okay. So with the buildings as well, we sort of made this little giggle with Dwayne that from a Topo50 point of view, I don't actually really care about those buildings turning up, because when those buildings do turn up, I'm just going to turn it into a residential area, and there's going to be
it's kind of grey underline.
Everything's going to be taken out. But what we are caring about is that with those outlines, we're getting lots and lots of very small buildings, and we've got to turn that back into, this is a 1 to 50,000 representation. So how do I show these 3 buildings here when I've only got space to show 2 points on the map? And so that's where our generalizing techniques come in. And then we kind of fall over a bit as well, because now we've got buildings within shelter belts. So when you look at it on the ground, it's going to be right under that shelter belt. It's going to go through. But
can you zoom in and show us that one, Karl? I think we looked at that one yesterday, didn't we? Or somewhere near there. You can kind of see the difference between topographic mapping and every other kind of mapping. I guess it's kind of, it's a representation rule based. What's going on there? Maybe just
no, we're streaming at 89%, so it's just a network thing here.
Okay.
So trust us that this area here there's about a 30-meter difference between where the shout about and the track is. And this is, as cartographers, we should be saying we're not going to show the shout about because the track's more important, because it's going to show access to buildings and that type of stuff.
So there are, you described yesterday, there are a couple of different kind of, you were describing the road and the bridge and that kind of topological effect where you might need the visualization might be just a fraction different than the actual data for the purpose of understanding in the field. So it's kind of a level of detail that we don't usually have to worry about when we're doing, if I call it GIS mapping, mapping out data. Cool. Thanks,
so this is what we could actually leave our LDS because it's not responding.
It's all right.
It's the frustration of our public, I'm sure.
Should we have a look at tile indexes? Do you want to try it on mine for a while?
We'll just get.
Looks like yours is some.
So we tried.
There's a link in that Topo data links if you want to, but it just brings you to the index.
Yeah, I think.
Should we try it on mine?
If you got network,
yeah,
we'll do it, and I'll just talk to it.
We'll just match it for give you a rest for a second. So, folks, we we unfortunately got moved out of our room that I had thought I'd booked, but I hadn't booked. So Karl and I are just in the office. So if you hear some noise from time to time, it's just folks in the office doing stuff. But here we are. I'll just hide that.
Cool. So we produce these tile indexes, and the tile index series is around how we share our data, and it's related to LiDAR and imagery. And what it does is our Topo50 map index, we have overlaps and that type of thing. So we have part sheets, and we're not going to show a sheet that shows 20 or 30 square meters of land. We move those sheets. And be careful when you're using our tile indexes here, because these are around standard naming. The naming has always sort of been standard, but the actual features that we supply haven't been. And this is breaking the country up into 1Ks, 50K, 5K, and 10K indexes. And they are true to the Topo50 layout. If you put in Mapsheet index, I think we decided yesterday was a difference. Yep.
So let's just check this one, maybe this has got our links all set up for us. Yeah, there we go.
Cool. So you see along the coast where we've moved that Topo50 map sheet index within the Topo50 tiles. Yeah, Bay of Plenty there has got a couple of good sheets that overlap. And then if you could scroll down on the the index, actually go to the top, because this was an interesting one. No, it's not. So when you do a straight LINZ map sheet index, the NZMS 260 sheets come up first.
Just map sheet index.
Just even get rid of the
that one.
Yeah. So the reason that comes up, you can see it hasn't been updated since 2013 because it had 50,000 hits before it was deprecated. So that's another sort of nice thing about the LDS. It's searching, it's returning on those 50,000 downloads because it was a very popular index, and you can see our Topo 50,000 indexes at 22,000 downloads.
You can see the difference there, eh? That's the NZ map grid that occasionally you see the odd one, but you can see their landscape.
Yes. And
the others are portrait. So it's a nice, easy way to remember. If it's not portrait, don't bother with it.
So that was directly, I believe, the story goes, from police wanting to, so you could actually, people could tell whatever map they had, because they were concerned about, one of the uses of our Topo50 maps that it gives you a reference, a 6-figure map reference that you can put when you're in trouble. The reality is that if you quote NZMG or NZTM to people, the numbers don't overlap. You can tell what's X and what's Y. That actually doesn't matter if you're skilled in understanding what those coordinates are, and these are all deliberate things that have been done in the creation of it. So YX, XY, don't worry. Well, do worry. If you can get it right, get it right. But those numbers are different, and systems should be able to interpret the difference between the two.
And we have a projections, datums, and coordinate systems webinar coming up that I hope to involve 2 or 3 folks from around Aotearoa to help us out with that one. Cool. Thanks, mate.
So,
what did we have next? Sheets versus tiles. There we go.
Yeah, we've done that.
And then having a look at the topographic data categories.
So that's the dictionary. So we've done that.
Oh, we've done that one?
Yep.
That one there?
Got out of order, sorry.
Oops. So let's have a look at what is in the Topo50K data. And if you have any questions, feel free to add them in the chat. Just avoid the Q&A if you can, just add them straight into the chat. But we've got them sorted here by most popular. So the winner is contours.
Yeah, and I'd like to, there's some stuff going around now and they reckon that parcels are the biggest download. I'd question that.
We got, if someone else wants to have a look on online for us, 142,000 users, but of course, contours, would you stream contours? Parcels you probably would, wouldn't you? You'd use the API on this, but contours, you probably download them.
Yeah, and we can't really work out why so many people have downloaded them, and maybe they've created the 8-meter dam themselves. It's a massive data set. You can't download it all at once. It's an interesting figure to see there. And again, it might be this historical thing where, you know, because we haven't had this LiDAR and the data, these contours tell us a lot about the elevation and access, and where our rivers are going to flow, and this type of information as well. So I think it's really underestimated that we are producing a 2D map, but probably the most important thing on it is our contours.
Yeah.
So people are walking, they can see the 1K grid square, that's fine, but if it's going up 5 contours, you're not actually going to be able to get up there.
And are they straight copies of the contour lines you see on the Topo maps?
Yes, they are.
And
so
how were they made?
How were they made originally? We go back to our NZMS 260 days. That's photogrammetry. So this is lots and lots of stereo models, stereo pairs, very skilled operators that could run through contours. My most experience would be JK at CoreLogic now, I believe. Watching him run contours through forestry was amazing. You can work out how tall the trees are from the start, because you're looking at the stereo model, you've got your floating point. You can work out how high the trees are, where the ground is, and then run the contour through the trees. And an interesting thing, even around snow and ice, Otago Survey School has done some work with our historical imagery, and they've gone out and got new ground control from where it is now, and they've reprocessed all our old imagery, actually using triples rather than stereo pairs, and they were amazed how accurate our contours through the snow regions actually were. And again, it's because we chunked this information together in tiny pieces, accurate. And I think the worst thing that we did with our contours was probably me. We did a lot of work on our sheet joins. We've done line smoothing. We've cleaned them up a lot in making that map. And if you zoom out with the contours, and depending how slow your computer see that came in, when they actually draw, you can pretty much see the order that they're drawing in as the blocks that they were actually captured in originally.
Those tiles you mentioned yesterday, I think, is a really good point about the tiles are used for data transport, including LiDAR and others. So it's really useful to know that, that they're part of the explanation for why you'll see those. They're not coming up in this data set. I wonder if they'll come up in the rivers. I've seen them in the rivers sometimes.
Yep.
I seem to be getting a pretty good speed at the moment, but often you'll see this really fascinating tiling pattern, and you can see that it's not coming up. Just trying to get it.
Just zoom out a bit, and you can see there the density.
Oh, there it is. There, see there.
Yeah, you can see the density in different sheets. And that's just, people like rivers are going to map a lot of rivers. Of people like, the tree points would be something that, because we don't actually bother too much maintaining tree points. We take them out of water and that type of thing. The obvious fixes, but we don't actually bother changing our tree points right now. The Landcover research have done this tall trees work, and we've sort of looked at that with our data over the Wellington region. The really interesting thing about that was that when you have tall trees within planted forests, because they come up as big clusters, and we can pretty much predict that within 2 years those trees are going to be felled. So we'd look at it in the future. This was actually what drives our maintenance cycle as well, and understanding that we've got work to do in those areas. I have this thing where the future for us is that change finds us. We don't have to go and find change, so we're not wasting our time going through lots and lots of imagery to see that there's nothing changed, which is, we need to do that. But we really focus on that high value change and the important things. And, I say high value change. And so I've had a council come to us recently about a state highway that had its name changed. It's in one of our popular sheets, so we can't actually write that stock off and make the change we were due for September 2021, I believe. So this is talking about offset printing and print on demand. So all our popular sheets, we know what they are by statistics. We offset print because we get that really high quality print. But the problem is we pay $3.30 per print, and we order 1,000 or so at a time. So we don't write off stock. So we actually wait till those stocks go down, and we align that with our imagery capture and that type of thing. And when we make a mistake, like we did, so we then have to go out to the map center and paste addendums onto little stickers onto the map to say the hut that you see at that point is not actually there. And that's a really interesting story because we produced that map, and within a week of it being published, the Tramping Club had come back to us and said, "You've got something very, very wrong there." And we said, "Yeah, we do." So the only way that we could actually fix that, well, the cheapest way that we saw to fix that was actually go and put those stickers out. And it's a good experience unfolding 3,000 maps, putting a sticker on it and folding it up again. You find out who your friends are, depending whether they disappear for, it actually didn't take us that long. But then there's other areas where, we've had huts destroyed by slips that we had to get taken straight off the map. And I'm just conscious that we're going to get into question time. But we had a incident recently where we got, through our Christchurch office, got contacted by police saying that three different searches were done in an area because the trail had been changed. Rumour was the signage wasn't that great, people weren't following it, and they had an old map. And so when we looked at our stocks, we actually only sold 10 copies of that map a year. So the fact that 3 people, if they're following Mountain Safety Council's guidelines of taking maps out with you, they were going out and getting lost. So what we did with that map, because it was a print on demand, we actually updated it within 3 days. And the reason that we could do that was because we had all the data ready to go to apply those changes. The cartographer made the changes, and then that map was ready to go. And this is, I understand this, the system that we're using, that when we produce this data, it takes, we release it onto the LDS every 3 months. If somebody is then having to process that and put it into their own system, it's going to be a delay after that as well. So I think because we're halfway through the project, we are looking at having ways of getting our digital data to people quicker, and that was a good example of it. The thing that holds us back and the constraint is the fact that we need this common operating picture across all our organizations. So with these digital systems, and I think we showed that with that Maps Pass, because you've got a map, you don't have the metadata around it, and this data is going to organizations where that metadata is actually hidden from people. So we're big on, you should be able to click on that map, see the data, and then fully understand where that data has come from, and whether the one that you're looking at is the edition after or the edition before.
Karl, we've got a few more minutes there, folks. If you've got some questions, just feel free to put them in the chat there. I'm just thinking, there's a couple of key data sets that I have interest in around the Topo50, and that's the named rivers, which, if folks are not aware of, there are 2. There's the named river lines and the named polygons, different to centre lines, which of course seem to be probably historically more popular. The lines themselves, are they the same, essentially the same as what you're seeing on the topographic map? And what would your advice be in terms of trying to, say, label rivers?
Yep. So the river names, those pilots, yes, were done from our river centre lines. And if you could zoom into an area, maybe put the topo map on, it could explain it. So in our data, we have this geographic name point, and that has a name. And I think we've only recently just added the point size, which is kind of useful. So for our rivers, that symbol that you see there, nicely curved along the stream, we supply it as a nice useful point that you've then got to rotate and then add the information on yourself. So for a river, you could have anything from 1 to 5 different place placements of that name, and our rules say that we name the river with a smaller font. The closer to the source it is, the bigger the river is, we give it a bigger font when it's down by the coast. So, and it isn't obvious from a data point of view what that river, where that river name actually is, especially around the sources and the extent. So the river names project was an idea where we extended that river name as far up the river as we could actually possibly go with confidence. So this is where if locals have information about the branches and the river names at the top of these rivers, you know, feed them back into us and we can get it changed. So these names do appear in the topographic database, but they still don't appear under the river name polygons and center lines.
Right.
Sorry, on the river polygons and center lines. They are maintained now, so when we maintain our river center line information, we can do it. But again, this is one that was released, or it's had an update of August 2019. So that was put out again. It's had 15,000 downloads. We'll look at that again and decide whether that's a good thing to do. But we should be able to maintain that. And yes, they are most definitely linked from that data point of view. And I'll just chuck in there about our roads. So our road names we take from addressing. So yeah, road CL. So if you do road _ CL, you'll get the Topo50. No, road
_ CL.
Yeah. So over the past 4 or 5 years, we've actually done some work on our road center lines, and we're bringing the geometry to within 2 meters of the road center line from the imagery that we're capturing off. We've still got about 45 sheets that have been captured, but still haven't been gone. You know, their data update hasn't gone through. But road names are an important thing. So we take all our road names from our AIMS address. Yep, and we have a road name ID in our Topo50 data. And so when we're doing our road QA, an example is, you know, whether it's named incorrectly or we've got a query about it. I had a road name down to a par that we were questioning. So while I'm doing my QA, I can place a point on the map, and when I close off my job, we've got this cool thing called a data pipeline, and I've done a video about that in another place. So you're inside your GIS system. You've finished the job. We've placed a point with a little comment on it, and that actually gets automatically sent to our external LINZ addressing query site. That gets picked up by our addressing team. They work on it because they've got the contact with the council to have, you know, to get those names sorted out, and we'll get an email back sort of within a week with the answer. It'll probably change both systems. So if it's a change in AIMS, they'll add that as well, and we'll add it into the Topo50 data. But this is where we, you know, focus back on cartography and get and leverage off the work that our addressing team does with councils. So we did have a question.
Yes, there's a question here. Let's see. I'll just see if I can find that. It was in relation to how often is the imagery captured and renewed into the database, and does it vary depending on priority areas that need updating more often, such as cities, as opposed to rural areas that have less change?
Yep, so that's a great question, and I'm pretty passionate about the West Coast on this one. So if you leave it there, Dwayne, because I can sort of relate to those two things. So if you look back when we were doing NZMS 260s, and this is why those ortho layers are on there, we did 20 sheets a year, and we actually purchased the imagery. And you know, that's LINZ doing it. It cost us a lot of money. And so we did a lot of work around our partnership program. And so that's Andrew Farrell here with the imagery team, and Bjorn Johns with our LiDAR. And so the idea was that we co-fund all the imagery that gets purchased. So we put a little bit of money towards the regional councils for the regional and city councils for purchasing. So we have no real say, but we certainly have a little bit of budget. And that's what our part of the deal is, that we actually maintain it and make it freely available through our, you know, Creative Commons. So the it really varies on what the councils are getting. And we have very little control. So we had a bit of control around the Kiwi Image project when that was underway, and the idea was that, you know, 60 centimetre satellite imagery was good enough to do all this work, and that got a lot of the country covered. But now it's about partnerships and sharing, and the giveaway on that is that I never have the same imagery over a Topo50 map. So from my point of view, it's really annoying. The good part is that there's lots and lots of areas where we have really high quality imagery, and it's only getting better. So Dwayne, if you want to search the imagery surveys layer.
There we go.
Okay, so if you click that on.
Just get rid of some of these.
Cool, and then just click anywhere and you'll see. So this is the index of every bit of imagery that we have. And so when we're doing our Topo50 update, I do have an index. It's not publicly available, but we do have an index of what we've actually used to update those sheets, and it's really enjoyable bringing all those different sheets together. But hurrah, we have this LINZ aerial base map service, and that's awesome because that puts everything together for us. When our team are doing building capture, for instance, they're capturing off a single source of imagery, which might have been overwritten in the base map service. And it's really important for them because they do have to define that source. So we've got these different user stories that, with our base maps, we can see New Zealand stitched together as one with the latest and best. And that creates a problem within itself because sometimes the best isn't the latest. So we have urban areas around the Waikato, which are 4 years old, but there's rural stuff that goes over it. And so it's easy for Topo50 because the rural is far, it's good enough for what we want to do.
I guess just thinking, it's just a little hard to find the question from time to time here. Urban areas, in terms of topo, I guess my feeling would be it would be less of a priority in urban areas for topographic mapping because you're just putting residential blob.
Yes.
So the focus is on search and rescue areas, mountain safety, and I guess the topographic data all began from military uses back in World War II and the rest of it. So I think in terms of how often it's updated, there's it's not necessarily the same as what you might expect from, say, Google Maps, which would be based on the most popular.
Correct, and that's
places.
where it's really good that like the likes of NZTA provide their corridor of highway, because that's given us a lot of our northland towns. We can get quite very high quality, and that corridor actually covers those important things. Just scroll down to the west. Okay, so you see the white, and that's that's a terrible thing.
Yeah,
can't stand the white gaps. And Mountain Safety Council, they have done these amazing videos on YouTube. Quite nice films have done it, and they create these 3D photogrammetric views, or 3D views of the images and stuff, and then they take our tracks off the LDS, and then they actually sort of superimpose those over the images, and they make these absolutely wonderful videos that support their getting outdoors safely things. But they come to me and say, when's the imagery for this when is it going to turn up? It's just not, and the sad thing is, it is around those priorities. So I don't know if we could set up a Give a Little page or something, or we need to find a better way or another way of actually doing that, because unfortunately we don't have that information in those areas. So the area that you're looking at right there, and then the one through the Southern Alps and the West Coast is one where there isn't very much on the radar. It's certainly you can see from the lines that it's been extended out, but that's a regular shape, not tiles, is actually particularly old imagery.
Yeah.
Whereas the more tiled is the more up to date West Coast stuff. But though those sheets there, we're trying to do roads on it. Absolute nightmare trying to get some decent imagery for that. And so Mark, given this, really interesting question. So we've done lots of work on creating 20-meter contours from a 20-meter dem, and that's where I come from, because this whole idea of that you create the contours from a 1-meter dem and then you generalize it up, it's just not the same. It just doesn't look right. And the story around the LiDAR is that is it enough for us to supply you with the LiDAR to run your own contours off it? Because to be fair, these are just basic tools that are run. If you're in a concentrated area, why would we spend the compute time doing 20, 10s and 5s if the use isn't there? And I'd take it a step further that, should LINZ be providing geoprocessing tools and TIN in the cloud where people can actually request their area? So rather than us going through and making 10-meter contours for the entire country, have a place where people can go and say, right, I want 10-meter contours over that area, and actually create that. Yep. And then that puts a responsibility back on the person to say, you're going to have overlaps, you're going to have all sorts of problems. We've seen them in our forest areas. It takes a lot of time to generate, really quickly generating, but it takes a lot of time to actually clean them up. And the thing about our contours is that's our labeling. So we always label our contours with the label facing uphill. So you can look at any map of New Zealand, and yeah, the label shows you the top and the bottom of the hill, and that's something that certainly in the northern hemisphere that isn't done. Contours just plonked on, and then labels are generated automatically, and you don't know which is what's up and down, sort of thing. Obviously, you click on the map and you get it, but sort of that's the time. And with the contours, again, because we're not getting these complete Topo50 sheet coverages to update our sheets, we're looking at updating parts of a sheet. And we've had interns in doing the work, and we've got some really good results around that we can get a 75 to 80% just cookie cut in and out contours, and then clean up the rest. And it's contours are a mess, because when you cookie cut them, you're going to get slithers all over the place and all sorts of things happen. So we are definitely watching that and waiting for that, and have, again, go back to us being lazy cartographers. Once we have the better tools to actually do the work, that's when we'll address that problem. So we've addressed updating our buildings, we've addressed updating our road centre lines, and water is a really big thing for resilience that we'd like to do next. And obviously with the PGF LiDAR being captured, that'll be the next one off the rank.
Cool. Well, thanks, Karl. That's all we have time for today, everyone. Hey, just big thanks, Karl, for joining us today. Really useful information. And that link, again, if you want to grab that document that we've been referring to, just put in the chat, is /Topo. Pretty sure it is. Let's just double check, make sure it is. All right, so that is us, everyone. Thanks again, Karl. Appreciate your time, and if you have any queries, just send them through to us. Are you happy to share your email, Karl?
Oh, most definitely. Yep. The other one will be I'm on LinkedIn. Lots of people hit me up on that. Cool. And yeah, open and honest discussions, and keen to hear feedback from people, and keen to help you when you come across something that doesn't look quite right. Yeah, that's cool.
Thanks, everyone. We'll see you next time. Ka kite.